This lesson we're going to learn about torque. Torque is a rotational counterpart to force. So just as we have linear forces, we have rotationally their counterpart is what we call torque. And so torque is found by, the symbol we use is this Greek letter tau. It's found by taking r perpendicular times the force. Now, what does that mean, r perpendicular times the force? Well, picture a wrench, and there's a nut here, and there's a wrench. So if I apply a force at the edge here, r perpendicular is it's called the lever arm, or sometimes called the moment arm, or the perpendicular radius. It's the perpendicular distance from the axis of rotation to the line of action. So let's write that down. Perpendicular distance from the axis of rotation to the line of action. Now, what does that mean, the line of action? Well, the line of action is if I take this force, for example, because it's r perpendicular times f, f is what determines my line of action. So I take and I simply extend this force vector. That's my line of action right there. So r perpendicular is the perpendicular distance from the axis of rotation, which is right here in the middle of this nut, and distance from there perpendicular to this line of action. That is my r perpendicular. So in the case of a wrench, if I apply the force perpendicular to the wrench, then the torque produced by that force is simply r times f. Now, what happens if I don't apply the force perpendicular? So here again, here's my nut, here's my wrench. So now suppose I apply my force at some angle. And let's just call this angle, well, let's find out. So if I extend my line of action here, there's my line of action, here's my axis of rotation, my perpendicular distance from my axis of rotation to my line of action, that is my r perpendicular, right? Right there's my r perpendicular. Now, if I look at r is the distance from the axis of rotation to the point where the force is applied. So if I look at this triangle, I've got r and I've got r perpendicular. Here I've got this angle right here. I'm going to call it theta. This is the angle between the force vector and the radius vector. And I can see I form a right triangle there because r perpendicular is perpendicular to that line of action. So I can see that r perpendicular is equal to hypotenuse, that's r, times the sine of this angle. So r perpendicular is equal to r sine theta. So one way to write r perpendicular times f is to write r times f times sine of theta. That's a way to find the torque. In a similar fashion, if I look at the same problem, there's my wrench, and I have my same force applied at that same angle. I'm going to blow this up just a little bit so it's easier to see. So I extend, here's my line of action here, my force vector. And this from axis of rotation along the wrench handle, that is my r vector. So this angle theta right here is this angle over here, right? So if I take this force and I look at this force vector here, and I draw a little triangle like so, I can see that this angle up here is going to be the angle in this corner here. This is the parallel component of the force. This is the perpendicular component of the force. So I can see that the perpendicular component of the force is the opposite side of this right triangle. It's equal to hypotenuse times the sine of theta. So just as I can take torque and call it r perpendicular times f, which we know is r times f times sine of theta, I can also do r times the perpendicular component of the force. So that's another way to find the torque. Now, how do I know which one to use? I use the one that's most convenient. Depends on what I'm given. This also brings up another concept in physics, which is what we call the cross product of two vectors. Because r is a vector and f is a vector. So what I really have here is what's called a cross product. It's R cross F. Now, these are vectors. So the R vector cross product the F vector. Cross product means I multiply perpendicular components. So cross product, multiply perpendicular components. And one of the ways to do that is to multiply by the sine of theta. So the cross product, R cross F, is equal to R times F times the sine of theta, where theta is the angle between the R vector and the F vector. So these are the different ways that you can find the torque. Now, in rotational motion, there are only two possible directions. You can rotate clockwise or you can rotate counterclockwise. So, clockwise or counterclockwise. Now, in the default direction, just as in a math class you have a default positive direction for x and a default positive for y, which you can change depending on the situation. You can decide what direction you want to be positive and negative. But the default is that counterclockwise is positive and clockwise is negative. So if you have no other reason, you can go with those directions if you want. Or that's something that you can alter depending on how you want to set up your coordinate system, and that's fine. Now, when you cross product these vectors, R cross F, an interesting thing happens. The direction of the cross product is perpendicular to the plane in which both vectors lie. So, perpendicular to the plane in which both vectors lie. For example, if I have a force vector that's horizontal and a radius vector that is vertical, then what's perpendicular to this plane is the one that's coming straight out like this. And so perpendicular to the plane, that is the direction of the cross product vector. Now, there's a simple rule for determining that direction, and that's called the right-hand rule. And the right-hand rule says that if I'm doing R cross F, I start at the axis of rotation, point my fingers of my right hand in the direction of R, and I curl them the easiest way towards F. My thumb then points in the direction of that cross product. So there are two possible ways. Notice if I get a counterclockwise type rotation, my thumb is pointing up. To get a clockwise type rotation with my right hand, my thumb must point down. It's kind of hard to see, but can you see that? And so really it's a way of helping to identify whether that torque would produce a clockwise type rotation or whether it would produce a counterclockwise type rotation. One last piece of information on our introduction to torque. Let's again take our wrench here. So if I have a force here, F1, and I have a force here, F2, and I have a force here, F3, if the magnitude of all three forces are the same, which one produces the most torque, and why? Well, if all three of them have the same magnitude, F1 will produce the most torque, because it's perpendicular already. So remember, torque is R perpendicular times force. So F1 is going to have the greatest amount of torque. F2 would be second because, again, that angle between the two, you're still going to have a component of that force that is perpendicular. That component will be smaller than F1, but that component will still produce a torque. And F3, notice that the line of action of F3 passes right through the axis of rotation. So when I do R perpendicular F, R perpendicular for F3, because the line of action passes right through the axis of rotation, F3 produces no torque. You can think of it this way. Will you ever be able to turn the wrench by pushing on it in this direction? No. F1, yep, you can turn it there. F2, harder, but it will still turn. F3 will produce no rotation, so there is no torque produced by a force whose line of action passes right through the axis of rotation.